Welcome back. Today we will be looking into a new topic called nonlinear relationships. And our first lesson will be on finding the x and y coordinates of a parabola, as well as using a table of values to graph a parabola. So a few things that we need to note is some really important things. A parabola is in the form of y equals ax squared plus bx plus c. Okay, you would have seen this type of formula in a topic called equations, or if not algebra. Okay, and a parabola basically looks like the following, right? I usually think about it like this. This one right here, y equals x squared. I normally call this like the happy face. Okay, that's how I normally remember it, because it kind of looks like a happy face if you put two dots there. Okay, then for this one right here, okay, y equals negative x squared. I normally call that the sad face, just so that I can remember. If I put two dots there, looks like a sad face. Okay, so that's how I remember those. Now, it is determined by the negative at the front here. Okay, if it's a negative, it's a sad face. If it is a positive here, so this must be a positive there, it's a happy face, basically. Okay, so let's get started. Now, with these parabolas, the A, so when I talk about A, this A right here, okay, if the A is greater than 0, what happens is the graph becomes steeper. So it becomes like this. It becomes closer to that y-axis, but never reaches it, okay? Then for the next point is if the A is less than 0, so let's say a fraction or so, then the graph becomes wider. So it becomes something like this. Okay, becomes wider. So that's the two differences, okay, that you need to look for. Now, let's go into an example. On the same Cartesian plane, graph y equals x squared, y equals x squared plus 1, and y equals x squared minus 1. So, simple thing is, use a table of values. So what I'm going to do is, I've got 3 equations, 1, 2, 3. And what I'm going to do is I'm going to draw up, which I've already have, draw up 3 table of values to show those 3 equations. And next to those 3 tables, I'm going to write down one of the equations that are in the question, just like so. Okay, then what I'm going to do is I'm going to just substitute. So in this case, for this one right here, my x value is -3. Okay, so what I'm going to do is I'm going to substitute. I'm going to go y equals. When I put this into the calculator, you need to have your brackets. So your bracket, -3, close the bracket, squared. Okay, this is very important. Okay, because it's all of -3 that's being squared. Okay, that should give you a +9. So that's what I'm going to write, +9. Then do the exact same thing with the brackets for your negatives, okay? Into your equation, this should give me +4, +1, 0, +1, +4, +9, okay? As you can see with this table right here, you can see that the y values, okay, whether the x values that you sub into the equation are positive or negative, are exactly the same. They're basically a mirror of each other. You need to make sure that that's correct. Okay. So let's do the next few ones. Okay. For this one right here, how you're going to put it into your equation is the same thing. -3 squared in brackets. So -3 bracket squared plus 1. Okay. Looking at my first table, I'll just add 1 to it, which equals to 10. 5 for this one, 2, 1, 2, 5, and 10. Simple as that. This one right here, same thing. Now you just need a -1 from it. This should be 8. This should be 3. This should be 0, -1, 0, 3, and 8. Okay, so it's very simple. Just put it into the calculator if you're not sure, but make sure when you put it into the calculator, you have the brackets for your negatives. So it must be bracket -3, close the bracket, squared. Okay. All right, once I've done that, I need to draw a Cartesian plane. This is a Cartesian plane. Make sure you know that it's your y and your x-axis. Your x-axis is your horizontal, y-axis is your vertical. Super easy. Then it needs to be accurate increments. Okay, it can go up by 2, or it can go up by 1, it can go up by 5. It's up to you. Okay, but it needs to be accurate for all of it. Now, what I'm going to do now is I'm going to plot this graph here, this table there, into my Cartesian plane. My coordinates, what it would look like is this column here. If I put it into coordinates, I'm going to write down -3, 9. So what I'm going to do is I'm going to go on my x-axis, find where -3 should be around here. Then go up to 9, should be here. Okay. Then I'll keep going. -2, 4. So -2, +4. I'll just put a dot. That's all I do. And I'll keep going. -1, 1, 0, 0. Then 1, 1. As you can see, it's a pattern. It'll be 2, 4. And then 3, 9. +3, going up to +9. Now what I'm going to do is I'm going to draw it. Just connect the dots. Do it the best way that you can. Doesn't have to be perfect. Okay, once you've done that, you're going to label it. This is y equals x squared. All right, let's do the next one. All right, -3, +10. That's my coordinates. So let's go to -3 and +10 for this next one. -3 is here. Go up to +10 right there. -2, 5. -2, 5. -1, 2. 1, 2. And then it'll be 0. So this is 0 here. 0 going up by 1 right there. 1 should be 2. 2 should be 5. 3 should be around here. It's going to go to 10. All right. You don't always have to use a different color. Okay. Especially if you're in an exam. That's why we need to make sure we're labeling our graph. Okay. So I'm going to label this one as y equals x squared +1 for the red one. All right. Lucky last. Let's do it. -3, 8. So I'm going to start off at -3. -3 and going to 8 should be around here. -2, 3. -2, 3. Then -1, 0. 0, -1. Around about here. 1, 0. Then 2, 3. About here. 3, 8. So I'm going to use my green, and I'm just going to go around. If you're doing this in an exam, right, just use a pencil, right? Plot it and just graph it, or just connect the dots, and then use your pen right after. Okay, one thing that I do not want to see if you're doing this in exam is this, like a sketching thing, like you're an artist. Okay, that's not it. I want one consistent line. That's why using a pencil before you use it in pen, that'll be great. Now, try your best. It's not always going to look perfect, but yeah. All right, so that is example number 1. Now, what I want you to do is comment the trends from these graphs. When you comment the trends from this graph, just look at it. So my original graph is the blue one, right? It's where the origin is at 0, right here, right? If I look at the red graph, what happened from the original blue going to the red? Well, it actually went up by 1. The shape of it is exactly the same, but the whole graph moved up by 1. So what I'm going to write down is I'm going to write down for y equals x squared plus 1, it has the same shape, okay, the same shape, but it moved up by 1. Now, for y equals x squared minus 1, okay, so going from the blue going to the green, it basically went down by 1, okay? It has the same shape. Has the same shape, but it moved down by 1. Okay, when I talk about the same shape, it's whether it's steep or it's wide, okay? In this case, it is your normal graph, y equals x squared, okay? The shape is the exact same. It's just moving up or down. So if you notice right now, okay, if you notice right now that this -1 or this +1, that constant is basically telling us whether it's moving up or moving down the y-axis, okay? Hopefully that makes sense. All right, I'm going to stop here and I'm just going to make a part 2 of this. So I'll see you then. Bye.